Dear students, now we are going to see the evidence for the structure of benzene. For this, three evidences are there. One is analytical evidence, second one is synthetic evidence, and the last one is other evidences. So we'll see one by one. So first one is analytical evidence. Elemental analysis and molecular weight determinations have shown that the molecular formula of benzene was found to be C6H6. So this indicates that it is a highly unsaturated compound. Why? Because we are comparing the molecular formula of benzene with the aliphatic compound that is having same number of carbon atom, that is called as hexane. So the molecular formula for hexane is C6H14. While comparing with these two, both are having same number of carbons, whereas what about the hydrogen? Benzene is having 8 hydrogens less. That's why that indicates it is having marked unsaturated properties. Again, we'll revise. Elemental analysis and molecular weight determinations have shown that the molecular formula of benzene was found to be C6H6. So that indicates it is a highly unsaturated compound. Why? Because we are comparing this one with the hexane. So here number of carbons would be same, whereas the number of hydrogen for benzene that is having 8 hydrogens less. So that indicates it is having marked unsaturated properties. Next one is synthetic evidence. Under that, 3 points are there. First one is presence of 3 double bonds. Next one is having aromatic properties. Last one is evidence for the ring structure. We'll see the first one, that is presence of 3 double bonds. If benzene is treated with halogens, it can take up a maximum of 6 halogen atoms. And if it undergoes catalytic hydrogenation, the final product formed is cyclohexane. So that indicates here it takes up maximum of 6 hydrogen atoms. Benzene is treated with ozone, it forms a triozonide. So these three reactions indicates that it is having 3 double bonds. That is, benzene is treated with halogen, it takes a maximum of 6 halogen atoms. On catalytic hydrogenation, it forms a product called cyclohexane. So that indicates that here it takes up 6 hydrogen atoms. It forms triozonide while treating with the ozone. So these three reactions indicate that it is having 3 double bonds. So next one is having aromatic properties, that is straight chain structure is not possible. Benzene will not react with the cold alkaline permanganate, but it can react with the hot alkaline permanganate and forming a product called as carbon dioxide and water. That is, on prolonged boiling we can get carbon dioxide and water. Benzene is treated with the halogen. In the absence of sunlight and the presence of halogen carrier, it undergoes substitution. So benzene is treated with water. In the presence of an acid, it will not undergo any reaction. So in the presence of acid, it will not react with the water. And it will not react with the halogen acids. So these reactions indicate that it is having 3 double bonds, and these double bonds are different from aliphatic double bonds, and that confirms it is having aromatic properties. And last one, evidence for the ring structure. Benzene is treated with 3 molecules of hydrogen in the presence of a nickel at 300 degrees centigrade and 30 atmospheric pressure. It forms a cyclohexane. So the formation of the product cyclohexane indicates that the starting material is also having cyclic nature. That is, cyclic structure of benzene would be confirmed, and also the presence of 3 double bonds. And the benzene is treated with the bromine in the presence of FeBr3, it forms a bromobenzene. So this product indicates that the 6 carbons in benzene are joined together to form a closed ring, and 1 hydrogen atom is attached to 1 carbon atom, and all the 6 hydrogen atoms were identical. And already we have seen it will not react with the halogen acids. So these 3 reactions indicate that it is having a ring structure. So that's all about the analytical and synthetic evidence. Next class we'll see other evidences.